Hello, this is a little presentation on solving inequalities with the modulus. So these can be pretty tricky. You get simpler ones like this. If I can just go straight into an example. Apologies if my pen's writing not so good. It's just eating toast and I've got butter on the graphics tablet. It's bad. Okay, let's just solve, which obviously means in an inequality sense, find the range of values of x for which 3x minus 1 modded is less than 5. This is what I would describe as an easier one. Yeah. Now, there's different ways you can approach it. Some people suggest squaring both sides. I don't like that in case the right-hand side is negative because it fails. It simply fails, that method, if the right-hand side is negative. It only works if you've got both sides positive. So I don't like teaching it. I would prefer just like a graphical approach because you have to draw these graphs sometimes, and so I think drawing the graph is a good way to solve it. If you think about what y equals the mod of 3x minus 1 would look like, it would be one of the bouncers because it's the modulus of a function. And so if I draw it in a different color, let's draw it in blue, it's going to hit the curve. It's going to have a gradient of 3, so it's going to be quite steep. And it's going to hit the curve when x is a third. I hope you agree. And it's going to hit the y-axis when y is 1. Because when x is 0, y is 1. Okay, we're trying to find where that line is less than, well, if you consider the other line y equals 5, yeah, if we draw y equals 5 on here as well, it'll be like up here. And sorry if that's a little unclear. Let me just make that a bit clearer what's going on here. So the blue one, the light blue one, why did I use two blues? The light blue one is, where's the pen gone? There it is. That one. Whereas the dark blue one is just a line y equals 5. Yeah? So y equals 5 is there, where y equals 3x minus 1. Well, that's modded. That's the V-shaped one. Okay, now we can actually solve this because we're just looking for where the light blue one is underneath or less than the dark blue one. So we really need to know the values here and here. Yeah, we need to know those x values. Now let me get some of the stuff out of the way because clearly some stuff is in the way here. Let's get all of this stuff out of the way. So I really want to know those points there and there. Now we've done this before. I've shown you examples like this before. We just simply have to say, well, okay, if you want to find this point, that point is where 3x minus 1 is equal to 5, in which case you're going to get x is 2. So we know that that x coordinate is 2. Cool. This one, well, this line is actually the line 1 minus 3x. If I was going to consider what it was, it's part of the line segment 1 minus 3x, and I get that by just multiplying 3x minus 1 by minus 1, and that's the line 1 minus 3x. Now I can just say 1 minus 3x equals 5. And then that gives me minus 4 is 3x, I think, doesn't it? Yeah, and therefore x is minus 4/3. Cool. I can now solve this, yeah, because I want 3x minus 1 to be under 5. Well, that happens provided minus 4/3 is less than x, which is less than 2. We have a bounded inequality for our answer, yeah? I will show you the alternative approach, even though I don't like this approach. So I'm just going to put, I don't like this, but it does work. It does work provided, and people often forget this, it works provided both sides are positive. So you could square both sides. Yeah, and you'll think this is quicker, and you'll think, oh, well, I like it, Mr. Nichols. Well, fair enough. If you square both sides, if you square a modulus, it gets rid of the modulus. Square 5, you're going to get 25, yeah? And then multiply out the brackets, 9x squared minus 6x plus 1 is less than 25. Take away the 25, 9x squared minus 6x minus 24 is less than 0. Divide by 3, I guess. 3x squared minus 2x, what's that divided by 3? 8. It's very early in the morning for me here. Factorize 3x and x. I'm guessing one of them's x minus 2. And the other one must be x plus 4. And so you get, this is a quadratic inequality, remember? So you've got to treat it like a quadratic inequality. So at the end, you have to draw your little quadratic inequality. It's going through minus 4/3 and 2. I describe these ones as bids because it's less than or equal to 0, less than 0, strictly less than 0, and you get the same answer. Okay, and that will work, that method, if and only if the right hand side is positive, and clearly 5 is a positive number. Okay, that's a basic one. Let's do a more difficult one. The more difficult one, perhaps squaring both sides is the easiest way to do it. I'm going to do 3-part F, or I, sorry, from the exercise. So solve 2 mod of x minus 1 is less than mod of x minus 2. Yeah? Now, straight away I'm going to say, as this is positive, yeah, and the modulus is strictly positive, what I could do is times that 2 into the modulus function. Like, there's no harm in doing that. It won't change anything. The modulus almost works like a set of brackets. Be slightly careful sometimes, but I could certainly multiply that 2 into the modulus function. It's not going to change anything, but we don't need to, actually. So let's do 2 methods again, because actually the more I think about it, the more I think, oh, you'll probably like the square both sides. But be careful. There are occasions when it fails. Okay, so sketch it once again, yeah? Now, if I was going to sketch, if I make it clear right at the start, the red one's going to be this one. Red one's going to be on this side. And let's have the other one in a nice bold colour of blue on this side, yeah? So I'm going to sketch the red one first. So I'm going to sketch y equals 2 mod x minus 1, yeah? Okay, that's going to be just like the curve y equals 2x, well, just like the straight line y equals 2x minus 2. It's going to hit the x-axis at x equals 1, and then it's going to bounce. When x is 0, y is going to be positive 2. Yeah. Now try and show the steepness when you do something like this. Like, I know it's not easy to do, but show that that's roughly got a gradient of 2. Yeah, and actually write the x and y intercepts on there. Yeah. Hopefully you agree that that's what that one looks like. Now y equals x minus 2 modded. That's not going to be as steep, yeah? It's going to be like flatter. Yeah, let's draw it like that. It's going to be more like that. Yeah, it's not going to be as steep. You want to detect the gradient. It's also going to hit here at 2, and then it's going to hit the y-axis at, I think, 2 as well, isn't it? Yeah, when x is 0, y is 2. Oh, that's handy, actually. That's saved me a job for later. Okay, what we want now is we want the red curve to be less than or underneath on the graph. Less than will mean underneath. Oh, let's get that colour off because that might confuse you. We want the left-hand side, the red curve, to be underneath the blue curve. Yeah, that's what we really need. Well, we can see one of those values straight away because they happen to intersect at x equals 0 and y equals 2. Yeah. All we need is this value here, and then we can tell you when the red curve is underneath the blue curve. Yeah. So let's do that. Now, if we're going to find that, you need to recognize that this is a straight line to y equals 2x minus 1. Yeah, if you just ignore the mod and treat that as a normal straight line which goes down there, that would be y equals 2 bracket x minus 1. This line here, this is the more complicated one. I've got to find where it hits that line. Now that's the line y equals 2 minus x. You can just turn around or multiply by minus 1 everything which is in the modulus. And then I'm sure you'll agree this is a gradient of minus 1. It goes through a y-intercept of 2. So that part of the V-shaped line, that straight line, has the equation y equals 2 minus x. We can now find where they intersect. We can just say 2x minus 1 equals 2 minus x. So 2x minus 2 equals 2 minus x. And so 3x equals 4. And so x is 4/3. And so we're going to get 0 is less than x, which is less than 4/3. Because all the way along here, the red curve is underneath the blue curve. Done. Okay, I suppose you want to see the square both sides approach. Okay. Alternative method. 2 bracket or mod x minus 1 is less than mod of x minus 2. Now this only works if both sides are strictly positive. I know I keep saying that, but it's so important. Square both sides, you get 4x minus 1 squared is less than x minus 2 squared. For x squared minus 2x minus plus 1 is less than x squared minus 4x plus 4. 4x squared minus x squared is 3x squared, minus 8x plus 4x is minus 4x, plus 4, I think that cancels with the other 4 on the other side, so you get that. Factorise, well, take out the x and have 3 minus 4x. You've still got to draw your quadratic at the end. Oh, let's do it slightly neater than that. So quick drawing sketch of a quadratic, doesn't have to be brilliant, but that's supposed to be a 3 in there as well, and it's really looking like a 1. That's a 3, yeah. And so it goes through 0 and 4/3, and we get exactly the same answer because it's going to look like that. That's 4/3. We want it to be under 0, and so you're going to get 0 is less than x, which is less than 4/3. Okay, both methods are useful, I guess. Both methods are useful. Those are tougher questions on the modulus, but they definitely come up, so don't think they don't come up. Good luck in that exercise 1G. I think you should do pretty much all the questions right the way up to and including question 11. Yeah, good luck, and contact me if you get stuck. Okay, bye-bye.